Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition. We're doing problem number 3.19. It says a mixture is 10 mole percent ethylene glycol, 75 mole percent ethyl acetate, and 15 mole percent acetic acid. Calculate the mass fractions of each compound. What is the average molecular weight of the mixture? What would be the mass of a sample containing 25 kilomoles of ethyl acetate? Okay, so let's do 319. Okay, so let's write down what we've got. We know that, so X is going to be my mole fraction, and so X equals mole fraction, and I'm going to say W equals my mass fraction. Okay, so the first is, too bad all of these are like the same initials. So we've got an alcohol, so we'll call that ethyl alcohol is the OH. That's my alcohol. And that one is 0.10 mole percent, or mole fraction. And then we've got ethyl acetate. Ethyl acetate, that is 75. Just notice there's 3 significant figures there, so we'll put that in there. And then we've got acetic acid, so that's AA, acetic acid, and that one is 15. Okay. First thing he says, calculate the mass fractions of each compound. So we know the mole fractions, we need to convert these into the mass fractions. So typically for these problems, you'll do you'll say, okay, if I had 100 moles of this mixture, what would the mass be, kind of thing like that. You could take a molar mass, or you could take some sort of 100 gram basis or 100 mole basis or something like that, and then kind of work from there and see, okay, if I had started with 100 moles, I would have this many moles of each of these compounds, and then I could calculate what how much the mass would weigh of each of those. So that's kind of the approach we can take here. So let's go ahead and say we have, let's start with the basis that we just have 1 mole of this mixture. So if we have 1 mole of this total mixture, that means that this is a true statement. So we have 1 mole of this mixture. If I add up each one of these things, then we have 1 mole. So that would mean that we have 0.1 mole of the alcohol, 0.75 moles of the ethyl acetate, and 0.15 moles of the acetic acid. Okay. So if that's the case, then we can calculate how much mass we have of each one of those things by looking up the molar mass and just converting each one of these to the molar mass. So molar mass of OH, molar mass of ethyl acetate, and molar mass of acetic acid. And that is 46.07, 88.10, and 60.05. We'll do kilograms per kilomole for each one of these. If we have 1 kilomole, let's say this is all on a 1 kilomole basis, then that means we have OH would equal 0.1 kilomole of the OH times its molar mass. Okay, and then this would be the mass of the OH. So we can just say the same for each one of these. And then this, the total mass, is equal to 79.69 kilograms. Okay, so if we have 1 kilomole of this substance, of this mixture, then we would have 4 kilograms of the alcohol, 66 kilograms of the ethyl acetate, and 9 kilograms of the acetic acid. Okay, and then we add up all those to get the total molar, the total mass of that sample. Then what would be the mass fraction of this sample? Well, the mass fractions equal the mass of the sample divided by the total mass. Okay, and so each one of these equals, okay, and that is the total mass fraction. So that answers the first part that it asks, what's the mass fraction of each of those? What is the average molecular weight of the mixture? Okay, so the average molecular weight would be, and that equals the mass fraction times the molecular, or the mole fraction times the molecular weight of each element, and this is a summation of the product of that, and that gives us the average molecular weight. So that would be, for the first one, I can write it out, it would be XOH times the molecular weight of OH plus XA times the molecular weight of EA plus the last term, okay? And then that equals 79.6, and if we look back at our molecular weights, it should be kind of the average of all of them, weighted by their mole fractions. So it'll be a weighted average of these, and so the highest one is 88, and the highest one also has the most weight to it, and so it should be closest to 88, and then the other two should bring it down just a little bit. So it should be slightly less than 88, probably like in the 70s range, and that's exactly what we see. That's in the 70s range, but still pretty close to 80s and 88. So, and then that would be kilograms per kilomole, the molecular weight. Okay, so that answers part. The next part, they don't have it broken into part A, part B kind of thing here, so that just answers the next part. What is the average molecular weight of the mixture? What would be the mass, kilograms, of a sample containing 25 kilomoles of ethyl acetate? Okay, so that means that the mass of ethyl acetate equals 25. Oh no, it's asking what is the mass, excuse me. What is the mass if we know that the amount of moles is equal to 25 kilomoles? What is the mass of the sample? And this is ethyl acetate. Okay, so something we could do is we say, okay, what's the total amount of moles that we have? That would be ethyl acetate divided by its mole fraction. And then we could convert the total amount of moles into the total amount of mass by multiplying it by the average molecular weight. And then that would give us the total mass of the sample. Okay? We can just combine these and just say M equals MEA over XEA times the average molecular weight. I just substituted that equation in there. And this should give us the mass of the sample, which is 26.60 kilograms of sample. Great. Okay, so that is the answer to problem number 3.19. Thank you for joining me on this problem. I hope that I presented the material in a clear way and that doesn't take too long to explain, but if you guys have any questions or need more details on how to solve this problem, just put some questions into the comments section, or any comments that you have. I can respond to those and start a conversation about different aspects of this problem that you need help with, or you think need a little more explanation. Anyway, thanks for joining me, and I hope to see you in the next problem. Thanks, bye.